All of you observe very carefully. So the concept what we are going to study in our today's class is measurement of atomic mass and molecular mass. Both I will teach. But you remember, if you are not responding, I'll cancel the class itself directly. So whomever, at least you have to involve in the class, then only it will be good. So all of you keep reading. Measurement of atomic mass and molecular mass. This is the most important concept for 10th, 11th and 12th as well as for 9th also. So all maximum interest here. I don't know how many of you, but you have to. So let us see now, everybody, all of you. So we all know basically if you go to the market, you can see that, for example, if you want to buy a vegetables. So if you see, we'll most probably, we all know in physics, we learn already beam balance. So from ancient time to now, still if you go to the market, so we all knows that there is a beam balance. Of course, still we can see nowadays electrical balances are there, but there is a beam balances we can notice still in the market. So if you want to buy, for example, 1 kg tomato, so how they will measure? Anybody? Yes, please. 1 kg tomato, how they will measure? One side there will be a 1 kg stone. Am I right? Yes, please, guys. There is a 1 kg stone and they will keep on putting the tomatoes. So wherever they will feel both will be equal, balanced, then they will consider as it is a 1 kg of tomato. Am I right, everybody? All of you? Yes, please.
Yes, sir.
Yes, no. So still if you want to be like 100 grams, 50 grams and all, you can see. So there will be a measurement of small stones, 250 grams, 50 gram stone, 100 gram stone, like that. So they will put it this one side and another side, they will try to put the material, and wherever they'll feel it will become balanced, then that is the equal weight or mass what you are getting, the vegetables and all. But if you take the atoms, as I said, what is the size of the atom? Anybody? What is the size of the atom? We studied at the beginning of this chapter. Anybody can tell? What is the size of the atom, please? Anyone at least? Size of the atom. Very bad. Size of the atom, please. Size of the atom, please. Size of the atom is measured in what? Atomic radius. Is it very big or very smaller? Size of the atom will measure in nanometers. 1 nanometer is equals to how many meters, everybody? Sorry, guys. We'll stop the class. No problem. Thank you, everybody. Okay. Leave from the meeting. Nice. I'm asking 1 nanometer is equals to how many meters? You studied or not, you can check it. A concept called how big are the atoms? That is the concept what we have studied. I want to know how big are the atoms. Even I have given the size of the different atoms also. Hydrogen, sulfur, chlorine, oxygen. Many atoms I have given you the size. So what is 1 nanometer is equals to, I want it. 10 power
9.
10 power
-9.
minus 9 meters. So if it is the tomato, if it is the brinjal, if it is the onion or something, they are big in size, in radius. So we can measure them normal with the help of beam balance. So beam balance is sufficient to measure when the size of the particles are bigger, but atoms are extremely smaller. So that is why it is not possible to measure them in a normal method, normal weight. I cannot put 1 hydrogen atom and measure the weight, 1 oxygen atom and measure the weight. So that is why. So atoms are so small. So because of this reason, atoms are extremely small. So they can see now, cannot be seen, everybody. They cannot be seen easily. So we cannot measure weight of the atoms, it is impossible because their size is extremely smaller, and we cannot even how much difficult it is to remember to measure the atoms individually. So we cannot measure the atoms of an element individually. That is why we will use a concept to call it as relative atomic mass. What is the concept we'll use it, guys? Relative atomic mass means comparison. Exactly like this comparison, we'll make it and we'll do it. So remember, what is this relative atomic mass? Of course, there is another method also, we'll do it. So this is the method A for atomic mass. Do it, everybody. Relative atomic mass. Relative atomic mass. The most important one in this entire chemistry, and we are going to learn this one is for further also. So relative atomic mass. What is this relative atomic mass? Means, all of you observe, when the, like, write it. When the mass of the element is compared, when the mass of the element is compared with some standard reference, some standard reference elements, then the atomic mass is called, then the atomic mass is called relative atomic mass. How much we used to call, everybody? Relative atomic mass. Just like how I measured 1 kg tomato with 1 kg stone. Like similar way, you have to measure it here. So how it will be? Let us see. Do you all understand what I'm saying, everybody? Yes, please. All of you.
Yes, sir.
So how means, sir? We have done in physics, I have taught you recently only. There is a concept which will start with the relative. Anybody tell me what is that concept name? Let me see who will say first.
Relative density.
Yes,
Relative density.
relative density. What is relative density? Anybody? Relative density means what? Anybody? What is relative density? Anybody? Density of any substance is compared with the what? Density of water at what temperature? 4 degrees Celsius. Am I right or wrong? All of you? So that is what? So density of any substance, you are comparing with the density of water at 4 degrees Celsius. That is what we used to call it as a relative density. Am I right? Mr. Lingesh, Nivedan, Shivani, no response at all. Are you clear, everybody? So relative density will give us what? Either the object will sink, or the object will float above, or the object above the surface, or float below the surface. Am I right, everybody? Is it right or wrong? Please respond, all of you. So comparison it is. So relative density will says how much times the density of a substance is heavier or lighter than the water. Am I right, guys? Please respond. Alfian, is it right? So the relative density will says that how much times the given substance is heavier or lighter than the water. Is it true or not? That is what is my question. If you say, I'll proceed. Otherwise, I won't. Anybody? For example, I'll say relative density of iron is 7.8. So what does it mean? Anybody can tell? What does it mean? Relative density of iron is 7.8. What does it mean? I'm asking you people. Hey, tell me, what is this nonsense? 9th class, you are all. Simply all are sitting like a dumb fellows. What you are thinking? You cannot do like this. I'm already telling you people. What do you mean by that? I'm asking. That is what nonsense people are doing. Always overactions only. Nobody is studying. All useless works means you will do it. Check your class works. Physics, take and see. Relative density of iron is 7.8 means density of iron is 7.8 times greater than density of water. That is the meaning of density, relative density is 7.8. Means, what is the density of iron? Check your notebooks and tell me. What is the density of iron? 7.8 gram per cubic centimeter. Am I right or wrong? Verify it. What is the water density? Density of water is how much, Ra? Such a worst. What is the density of water?
1 gram per
1 gram per cubic centimeter. That is
cubic
what is
centimeter.
relative density. Relative density will give us how much time the given substance is heavier or lighter than the water. That is the relative density. Same way here, same thing. We are taking as some reference element and we are comparing the all other elements, how many times it is heavier or lighter. That's all it is about. Okay. So that is only we used to call relative atomic mass. So now, remember all of you, olden days, very, very long back, people used to consider hydrogen is the reference material, reference atom. Hydrogen as a reference. But later, hydrogen is existed in different forms. That is why hydrogen is later not has been taken. So all of you observe. At the long back, many years before, hydrogen was taken as a reference. As we all know, says who is the first element in the periodic table? I already shown you also. Who is the first element in the periodic table?
Hydrogen.
Hydrogen. Hydrogen is the lightest element. Hydrogen is the what, everyone? Lightest element whose atomic mass we are not calculated. I am saying you atomic mass is 1U. What is the atomic mass of hydrogen, everybody? What is the atomic mass of hydrogen? 1U. Okay. So hydrogen is considered as the reference atom because it is lightest gas and mass of hydrogen was taken. Mass of hydrogen was taken as how many units, everybody? 1 unit. Purima, yes or no? Understand, everybody? All of you?
Yes, sir.
And then they are compared with the mass of hydrogen, any other element with the hydrogen. Means they will take, for example, again, imagine like a beam balance. Better than this, nobody can, I'm saying. So again, you imagine like a beam balance. And what is our reference material, everybody? What is our reference material? Hydrogen. Do you understanding, all of you? So now, I want to measure oxygen or carbon. Let me take. I put one carbon atom here and one hydrogen atom here. So it is imbalance. Like that, if I put six hydrogen atoms, understanding, then it is equals to one carbon atom, mass of one carbon atom. So that's why carbon is placed. How many times it is heavier, carbon? Anybody? Carbon is heavier how many times? All of you.
6 times.
6 times. That is why the position of the carbon, sixth position. You can check it. Now, if I take oxygen, understanding, 8 oxygen atoms will be, sorry, 1 oxygen atom will be equals to 8 hydrogens. Like that, then what is the position of the hydrogen? Sorry, oxygen. Check it, everybody. From the hydrogen, what is the position of oxygen? Check it. How much? 8th position. Do you all understand, Ra? Everybody? Please respond.
Yes.
All of you? So next, suppose helium. Second element is helium. Helium is how many times heavier than hydrogen? Helium how many
2
times heavier
times.
than hydrogen? 2 times. Lithium how many times heavier? 3 times.
3 times.
Understanding? Beryllium. One beryllium equals to how many
4
hydrogen
times.
atoms? One beryllium equals to how many hydrogen atoms? Everybody? Yes, please. 1
4.
4. That is what. I hope you all catch my point, everybody. So relative atomic mass of an element is equals to, write it. Relative atomic mass of an element relative atomic mass of an element is equals to mass of, note it everybody, mass of one atom of given element. One atom of given element divided by mass of one atom of whom? Everybody. We are comparing with what? Comparing with what? Comparing with which element, guys?
Hydrogen.
Hydrogen. So, mass of one atom of hydrogen. That is the formula of relative atomic mass of an element. Anybody having any doubt, you can ask me, or else you can proceed. I will say you. Nobody is responding. I'm saying you strictly from tomorrow, not responding, not ready to work. At least in chat, don't join in the class.
The one atom in the sense also.
If you consider like one atom of hydrogen and you take one atom of any other element, if you do the ratio, that is what relative comparison that I am saying you here see. If I take one carbon atom, I have to put 8 hydrogen atoms. Then only the mass, the weight of one carbon atom, atomic mass, which is equals to 8 hydrogen atoms. Do you understand? Sorry, 6 hydrogen atoms. Purima?
Yes, sir.
Yes. Anybody? Do you understand, Amma? So, at the starting, people used to consider ancient time. One hydrogen atom is equals to 1 AMU. That is what? 1 unit. Okay? So, 1 AMU. What do you mean by AMU? Anybody can tell? Atomic mass unit. What is that? Atomic mass unit. And future, later, we have been call it as a simply U. U means unit. Okay, atomic mass unit. Clear? Just comparison. How you are comparing tomato, 1 kg of tomato with 1 kg of ironstone. Same way, I am taking one atom of any element and comparing with the equals to how many hydrogen atoms. In based upon that, I am arranging. That is what is relative atomic mass. Do you all understand, everybody? So next. But later on, it was proved inconvenient as a hydrogen. Hydrogen is not giving exactly. What is the reason? Next chapter you will study. That is what reason behind why hydrogen is not considered future after this. Because hydrogen is having isotopes. Isotopes. Sir, what do you mean by isotopes means? Just I will say you now. And next chapter we'll study. Isotopes means, please note it everybody, same atomic number. What is the symbol of atomic number? Anybody can tell? I already taught you. Z. But different mass number. What is the mass number? Everybody. Respond, Ra. Different mass number. A. Okay. So that is what. Remember, isotopes means same atomic number but different mass number. So what exactly we will study in the next chapter? You don't need to worry. So anyhow, hydrogen is proved inconvenient because of isotopes. So that is why later, few days after, people are consider oxygen is the reference atom. Are you clear, everybody? Oxygen is the what atom? Oxygen as a what? Reference atom. So again same, after few days, after few years, they consider oxygen as a reference. Again, oxygen also same problem. Oxygen also having what? Everybody. Oxygen also having what? Isotopes. What do you mean by isotopes? By this time definition you must know.
Same atomic number.
Same atomic number, but
different
yeah,
mass number.
different mass number. What is the mass number symbol? A. Okay, wow. Girls.
Yes, so can we also say it as atomic mass? No, sir?
Yes, yes. Atomic mass or mass number. Okay. Shivani, Kavya, Hasini. என்ன பண்ண முடியாது தெரியாது. Okay, then what is that oxygen? Again same. So oxygen was taken as the reference, and you can see all of you. So now instead of hydrogen is the reference, we are going with the what? Again, imagine like a beam balance. So who is our reference stone? Who is our reference stone? Anybody?
Oxygen.
Oxygen is our
Oxygen.
reference stone. Oxygen is our reference stone. Okay, wow? Then you can see if I put hydrogen, how many hydrogen atoms I have to put? Everybody equals to oxygen. Yes, please.
8 hydrogen
8
atoms.
hydrogens. So before I said, check it everybody here, 8 hydrogen, oxygen, 1 oxygen equals to 8 hydrogens. So actually, what does it mean? Oxygen is 8 times heavier than hydrogen. Do you all understand, everybody? Oxygen is 8 times heavier than hydrogen. Am I right or wrong, everybody? Yes?
Yes, sir.
Now my
Yes, sir.
reference material is oxygen. So I should say it is equals to 8 hydrogen. So means hydrogen is 8 times less heavier than what? Anybody? Less heavier than
Oxygen.
what? Oxygen.
Oxygen.
So that is why hydrogen is placed 8 places before oxygen. 8 places before oxygen. Do you all understand my point? I hope you all understood. Everybody?
Yes, sir.
Clear? That is what is relative atomic mass of an element. Then oxygen also again problem. It is also discarded. Clear? So next, okay, there is a problem with oxygen, so that they have been considered. Next one is carbon 12 as a reference. I am using a word, call it as a carbon 12. Carbon 12 as a reference. So this is the most standard structure and available structure of carbon. It is not a carbon. What is this, everybody? Carbon 12 as a reference. So more stable compound, more stable structure it is having. So that is why presently what we are using as a carbon 12 as our reference. What is to call it, Amma? Carbon 12 is our reference. So now, what is the carbon atomic mass? Anybody can tell? Everybody? What is the carbon atomic mass? All of
6. 6.
yes, please. So carbon atomic mass. Ma, I told you to learn. Please learn. What is the carbon atomic mass? All of you. 6.
6, sir.
Next. What is the number of protons? That's what. Atomic mass is equals to, please note it, everybody. Number of electrons. What is that, everyone? Number of electrons. Sorry. Number of protons. Number of protons means,
Proton plus neutron, you have
yeah,
said, sir.
it is what we used to say atomic number. Sorry for that. Atomic number is Z. It is number of protons. Note it. So number of protons, how many are present? Anybody? Number of protons, how many are present in carbon? 6. That is what is atomic number. Okay. Now, carbon 12, please note it. This carbon 12 means it is the mass number. So mass number of carbon is 12 units. What is the mass number of carbon? Everybody? What is the mass number of carbon? 12 units. Prima means it contains 6 protons plus 6 neutrons. 6 protons plus, everybody?
Sir, always will it be equalized or neutral?
Neutral, always. But other forms will come. Carbon 13, carbon 14 also will come. That is, we'll study in the next chapter. Don't worry. Now, this is
Yes.
carbon 12. What do you mean by carbon 12? They will ask you. What is mean by carbon 12? Anybody? What do you mean by carbon 12? One carbon atom who is having 6 protons and 6 neutrons. Ellame understood? A carbon atom who is containing 6 protons and 6 neutrons is called it as a carbon 12 atom. Is it clear, everyone? Yes, please. Yes, sir.
Yes, sir.
Yes. So now, what do you mean by 1 unit, 1 ANU? Before I have taken One mass of one hydrogen is equals to 1 unit. Am I right or wrong? Everybody. Solunga thambi.
Yes, sir.
That is what. Now, the most standard form of atomic scale or atomic mass unit, AMU. So remember, if I consider this is the carbon 12 atom, like imagine watermelon. What is this atom name, everybody? What is the carbon? Carbon 12 atom. This is the atom of a carbon 12 atom. Carbon 12 atom. So how many protons and how many neutrons are there, everybody?
Proton 6 neutrons.
6 protons plus 6 neutrons. That is why, what is the atomic mass, everybody? What is the atomic
12.
mass?
12.
12 units. Clear? Everybody understand? Gokul, Darshan, that is. Now, take the scale and make it 12 equal parts. How many equal parts, everybody? 12 equal parts, this carbon atom. Just imagining, I am imagining. So, how many equal parts I made it now? Anybody? How many equal parts are? 12. So, only 4 I made it. Then, you can check it. Now, how many I made it? Total parts. Count it, everybody. Make it quick. Understand? Yes or no? Now you observe. So totally, I have not made equally, but you can make totally how many equal pieces, everybody? How many equal pieces? This I'm considering 12 equal pieces. Okay, so make it into 12 parts, 12 equal parts. Okay, everybody? Clear? Understand, Amma? Girls? Yes. Now, carbon 12, one piece of carbon 12 is considered as a one atomic mass unit. How much it is, everybody? One carbon 12 is considered as a how many units, everybody? One carbon 12 is considered as a how many unit? I'm asking you.
12.
Mass of one carbon 12 atom. That is what the one particular part. So you can notice it, all of you. You can see that watermelon. Yes, you can see. So I'm having a watermelon. This watermelon is actually a carbon 12 atom. What is that? That watermelon itself is a what? Carbon 12 atom. Now, I cut this watermelon is equals to how many equal pieces, everybody?
12
Please,
equal parts.
12 equal parts. Now, what is the mass of one piece? Anybody can tell? Use mathematics and tell me. Total mass of this 12 pieces is 12. What is the mass of one piece? Mass of one piece. Anybody can tell? Total mass is 12 pieces. Let me take it. What is the mass of one piece? I am asking. Everyone. Arey, what is that? What is the mass of one piece? 1 by 12. Am I right, Nivedan?
Yes, sir.
Yes or no? So, a mass of 1 by 12th of carbon 12 atom is only call it as a AMU. Please learn the most important definition. 1 by 12th of carbon 12 atom. 1 by 12th of carbon 12 atom exactly equals to 1 AMU. 1 AMU is equals to 1 by 12th, 1 by 12th of the mass of which atom? What is that atom name, everybody? C12.
12 atom.
That is what call it as a AMU. Please learn it. Define one AMU, the most important one. Okay, so that is what is actually. So please learn it, everybody. Expecting all of you understand. What is one AMU? What is one AMU, everybody? What is one AMU?
1 by 12.
1 by
12.
of the mass of the which atom?
Carbon 12.
Carbon 12.
Carbon 12 atom.
Carbon 12 atom. 1 U is equals to 1 by 12th the mass of what? Mass of carbon.
Carbon 12.
That is what we used to call it as a AMU. So AMU, you can see, we'll represent with the AMU, atomic mass unit with U. U means we can say unified mass, or we can say unit mass. Ellame understood or not? Everybody. This word is also there in our book. You all can see. Unified mass, it is there or not in our book? Somewhere it is there. So that is what it is, atomic mass. So you can see. So yeah, here. U means what, everybody? Before we used to write AMU. Now what we used to write, everyone? Unified
U.
mass. Okay. Who is referencing IUPAC? What is the full form of IUPAC? Anybody? What is the full form of IUPAC? I already taught you. What is the full form of IUPAC? International Union of
Pure
Pure
and applied
Applied
chemistry.
chemical.
Chemistry. At least learn that as the engineering students. In future, you will be. So everywhere you can see, we have to be like future. You may go to NEET or if you may go to everywhere. So the comparison of units and this organization, the IUPAC is the organization. Whatever you are going to learn in the chemistry, that is the organization which will suggest the names and fix the names for a given element or a compound. Maybe future you may be discover something or you may be invent something. If it is a chemical, definitely this is the organization has to get approval. Otherwise, your name is not allowed to publish anywhere. It is not considered as a valid name. That is what you have to remember. Anybody having any doubt in this? Please let me know. Are you clear, everybody? Yes, please. All of you. Now comparison. How to compare? All of you listen. So now, one watermelon piece. 1/12 of the watermelon. 1/12 of watermelon is equals to how many apples? Check it, everybody. How many apples?
Two
How many
apples.
apples? Two apples. Means imagine like it is like 1/12 of one watermelon, which is equals to two apples. Next, 1 by, understanding, 12th of watermelon may be equals to some other one, four apples or five apples or six apples, whatever it is. So that is what we used to call it as a atomic mass. So please remember, which is equals to how many atoms, which is equals to how many atoms. That is what it is actually. Now, if I put instead, suppose this watermelon mass is 1/12 of carbon, then you can see, I have to put here how many hydrogens. Anybody can tell? How many hydrogens I have to put, guys? How many hydrogen atoms? Everybody. 12. One piece, amma. So it is how many times? It is less than. Carbon 6, hydrogen 1. So how many hydrogen atoms I have to put? 6 hydrogen atoms I have to put it. Then only it is equals to a mass of 1/12 of carbon 12 atom. Do you all understand what I'm saying, everybody? So 1, all of you check it, everybody. 1 carbon atom is equals to 6 hydrogen atoms. Purima? Understood? Nata? Please respond. Everybody? So always we'll compare 1/12 of a carbon. 1/12 of a carbon, which is equals to what, guys? 1/12 of the carbon atom is equals to 1 unit. Please note it. Most important definition. Mr. Sam, understand? Alfin, Kavya, any doubt? Anybody can ask me. Hasini, Kishore, Lingesh, do it. So what is AMU? Everybody define AMU. All of you. Make it fast. What is AMU, guys? One AMU means what? 1/12 of the mass of C12 atom. So this is the most important one, and you have to learn this definition also. I will give you. Do it fast. Sir, 1 unit means how many grams, sir? That is very important. See that if I make the carbon 12 parts and one part, if I check it, one part, how many parts I should make? Mare, 12 parts. So
12
mass of
parts.
one part, you know, guys, how many grams? Why I'm taking 1U? Because values will come much differences. 1.6605 into 10 power 24 grams. Many people don't know, but your purpose I am teaching you. So 1 unit is equal to how many grams, everybody? 1 unit equals how many grams? 1.6605 into 10 power 24 grams. So, therefore, we can say the number of times an atom of that element is heavier or lighter? Heavier than 1/12. 1/12. 1/12. What do you mean by 1/12? 1/12. 1/12 of the mass of an atom carbon-12 isotope. Actually, carbon-12 is also isotope. Carbon-13 is there, carbon-14 is there, and carbon-12 is there. But who is the most standard structure? Majority is availability, carbon-12. Clear? That is what we used to say isotope. That is what you have to remember. Any doubt anybody can ask me. If you understand this, then only we can go. What is AMU, everybody? What do you mean by AMU, everyone? 1/12 of the mass of the carbon-12 atom. That is what we used to call it as a U. U means unified mass, or we can say what? U means, everybody, unit mass. Okay, all of you, I hope you all understand what is atomic mass unit, AMU. Anybody having any doubt, you can ask me. Are you clear or not? Respond, Ra. Everybody. Sure. Yeah, do it fast, everyone, and I'll send